In this video, we will investigate behavior of microwave using a partial polarizer. It's built using cable fibers that we can get from ordinary electronic cable. It's helpful to leave some of the cable insulation intact until the copper fiber is going to be fixed to the polarizer frame. The cable fibers are attached to a wooden frame using hot melt glue. The glue is chosen because it bonds fast and fairly strong. The space between copper fibers are 5 mm. As usual, we start by arranging microwave transmitter and receiver in vertical orientation. The distance is adjusted to get maximum reading scale on the receiver. When the microwave is parallel to the axis, it's only partially blocked. If the polarizer is rotated on vertical axis so it's no longer perpendicular to the microwave transmission path, there are more copper fibers get in the way. Hence, the receiver gets lower intensity. We can assign a number called polarizing index P to determine effectiveness of a polarizing filter. Alternatively, we can assign leakiness L to describe how much microwave in the same orientation as the polarizer can pass through. Just like normal polarizer, partial polarizer passes through microwave perpendicular to the axis. By rotating the receiver, we know that microwave passing through the partial polarizer still have vertical orientation without horizontal component.